What is Kubernetes? So Kubernetes is, we can spend a lot of time talking about Kubernetes. So I'll describe it briefly as it's a container orchestration system. And I think it's evolving over time. And one way you can think about it is it's an operating system for a new cloud computer. And it helps us sort of normalize the scheduling, the policies related to how you take a container and allocate it to resources. If that container fails, I should maybe backtrack a little and say what a container is. A container is essentially a unit of deployment of code, provides some isolation properties, kind of like a process on a Linux operating system, if you will, but now containerized so that you can actually make it a bit more portable. It's independent of the operating system underneath and allows you to sort of package your resources and libraries and dependencies into a repeatable unit of deployment. Now you need some mechanisms to run it. So Kubernetes really takes the infrastructure management, which is how you manage the resources, the servers, the networking policies, the storage resources, and allocate containers to those resources. And doing it in a way where, if a process fails, if a container fails, what do? You want a restart policy? Okay, great. You want a scalable process? You want a container to replicate itself because it has additional load? Maybe you can define policies around that. You want to mount volume into your container so you can persist data across container restarts? Well, Kubernetes gives you ways of doing that. So it's an infrastructure-focused technology. And I think it's seen a lot of interest in both the community, open source community, and in enterprise because of this idea that it helps to sort of shift the burden up from developers and operators in terms of the abstraction barriers to not focus so much on the underlying machinery, but move up a layer in the stack. You're still focused on infrastructure. And I think where serverless takes this is to the extreme. Don't think about infrastructure at all. So in some ways, serverless and Kubernetes are on different extremes, if you will, in the design space. And a lot of organizations are adopting Kubernetes, and we've talked to dozens of companies that already have Kubernetes expertise in-house. They're either using it on a managed cloud or they're deploying their own Kubernetes distributions on private infrastructure. And they're doing it largely because of this idea that, hey, it helps me free up resources, people, essentially, who are doing infrastructure management. I can get more value out of them in terms of my business. So it's good. But by itself, it's not a panacea. It doesn't solve all problems. And largely because it's still infrastructure focused. And where we've come at this from Nimbella and the serverless model is you don't want to surface Kubernetes at all to developers. Maybe in terms of the operators or somebody who's operating private infrastructure, they need to understand it. They need to deal with it. But from a developer's perspective, these are the kinds of things that you don't want to deal with because they get in the way of you writing code faster, of developing, iterating, and delivering and shipping code. Every little detail that you don't have to think about that distracts you from the business logic that you're trying to create is something we'd like to remove. And at our company, we've essentially embraced that notion of serverless, which is don't think about infrastructure, don't think about servers, focus on just your business logic. And we've taken that from just thinking about functions as a service, where Amazon Lambda started and where I had my roots into the space, to really encompass a whole notion of resources you want to use in the cloud without having to really deal with the underlying machinery of the cloud. So when you're deploying an application, if you contrast that between what you would do in Kubernetes versus a serverless environment, you can start with just your code. And from your code, if you can deploy that as a cloud application that's cloud native, meaning it uses all the underlying cloud resources natively as they're provided by APIs from those cloud providers, your applications are secure, tend to be more secure, they tend to be more scalable, more elastic. Whereas if you think about, I want to deploy this on Kubernetes, well, first you have to pick your Kubernetes distribution. Maybe it's a managed service. Then you have to write these specifications, the YAML specification typically that says, here are my containers, here are the pod policies, here's the liveness probes, here are the volumes I need to deal with. A lot of sort of friction enters into the process. So on the one hand, Kubernetes is great, and I think it's doing a lot in pushing our industry forward. On the other hand, from a developer perspective, I think it has a lot of room to grow in terms of pushing abstraction barriers up. And that's not for Kubernetes to solve, right? Linux doesn't solve the programming abstractions if you think about it as an operating system. There's many layers in our stack between the application code and the operating system. And so it is with Kubernetes. I think, that's why the analogy, I think, to an operating system makes sense to me. And if you think about what does the application layer look like, how do you bridge that gap from the application layer down to Kubernetes? That's where the opportunities are. And that's what really excites me about this space.